All right, let's get into it. There's a new frontier opening up. But, it's not on some far-off planet. Nope, it's right in the space above our heads, where an absolutely high-stakes race is just getting started. And this isn't a race for land, it's a race for the future of information itself.
And look, you might think this all sounds like science fiction, right? But when the CEO of Google, Sundar Pichai, comes out and says it's just a matter of time before we need this kind of insane computing power, well, a massive shift is on the horizon. This idea is what's driving a complete revolution in how we think about our data.
So what does a shift like that even look like? Well, it looks like this absolutely mind-boggling number, 500 gigawatts. That's the annual goal Elon Musk has for deploying solar-powered AI satellites into orbit. Just to give you some perspective here, the entire planet's current data center capacity is only around 59 gigawatts. We're talking about a leap in scale that is just unbelievable.
And this isn't just one company's crazy ambition. What we're really watching here is the beginning of a brand new space race. The titans of technology are all stepping into the arena, and they're all fighting for control over the next generation of our digital world.
The starting gun has already fired, believe me. You've got Google pushing forward with Project Suncatcher, and they want prototypes in orbit by 2027. SpaceX, of course, is beefing up its Starlink satellites to handle just enormous amounts of data. And Jeff Bezos' Blue Origin? They've been quietly working on orbital data centers for over a year. You even have other players like StarCloud getting in the game, literally sending powerful NVIDIA GPUs to space. The race is definitely on.
But it kind of makes you wonder, right? Why? Why are all these billionaires so obsessed with leaving Earth's atmosphere just to build data centers? What is the problem down here that's making them all look to the stars?
Well, here's the heart of the issue. In the United States alone, the electricity used by data centers is projected to rocket from just under 2% of the country's total back in 2014 to a massive 9% by 2030. To put it simply, the AI boom demands an amount of energy that's quickly becoming unsustainable here on the ground.
So here's the bottom line. We're caught in this perfect storm of push and pull factors. On one side, you have the push. Our data centers on Earth are consuming just enormous amounts of energy and water, and they're so vulnerable. It's everything from a cut undersea cable to an earthquake. There are also geopolitical headaches, with countries putting up walls around where data can be stored. But then you have the pull from space, offering these two incredible, almost perfect advantages: limitless solar power, 24/7, and the cold vacuum of space, which is the most efficient cooling system you could ever ask for.
Okay, so that covers the why. Now, let's get into the how. What does a server in the sky actually look like? What's the real blueprint for building this kind of thing up in orbit?
At its core, the concept is actually pretty simple. An orbital data center is basically what it sounds like. You take all the gear, the servers, the storage, the networking stuff, and you pack it into these specialized modules. Then you launch them into orbit and connect everything back to Earth with super fast links, like lasers.
And the key thing to picture here is not some single giant building floating in space. Instead, think of a constellation, like a swarm of smaller modular satellites that are all working together. They'd basically form a giant processing grid, a true network, orbiting our entire planet just a few hundred miles up in low Earth orbit.
Now, to actually make that happen, you need some seriously advanced technology. We're talking about compact server units that have been hardened to survive the constant radiation of space. Super efficient solar panels are obviously a must, along with advanced batteries for when the satellite passes into Earth's shadow. The biggest engineering puzzle is cooling, which needs these big passive radiators to just bleed heat off into the vacuum. And of course, you need laser communications for data and autonomous robots for repairs, because you can't exactly send a technician up there, can you?
But, and this is a huge but, building this is nowhere near easy. Space isn't just an empty, peaceful void. It is a hostile frontier. It's an obstacle course that's filled with dangers that could destroy this incredibly delicate infrastructure in a heartbeat. Which, of course, brings us to the obvious question. If the idea is so great and the money's there, what's stopping them from just building these massive orbital networks tomorrow? Well, as it turns out, the list of threats is pretty long and incredibly complex. The dangers are coming from literally every direction. Environmentally, you've got this constant bombardment of radiation that can cause bit flips, basically corrupting your data, and just wears down components over time. Kinetically, you have millions of pieces of space junk up there, where even a tiny piece the size of a nickel, traveling at thousands of miles per hour, can cause catastrophic damage. And the threats aren't just in space.
Back on Earth, you've got to worry about cyber attacks, or even physical tampering by an insider before the thing ever gets launched. And believe it or not, that's not even the whole story. Engineers also have to design systems that can handle wild, extreme temperature swings. They have to figure out how to do super complex repairs using only robots. And they have to make sure that adding all this new hardware doesn't trigger something called the Kessler syndrome, which is basically a nightmare chain reaction of collisions that could make low Earth orbit completely unusable for everyone.
So, with all of those incredible challenges, what makes this race even economically possible right now? And what could our digital future really look like if these tech titans actually manage to cross that finish line? This number right here. This is the game changer. $200 per kilogram. That's the projected cost to launch stuff into space by the mid-2030s. And it's all thanks to reusable rockets like SpaceX's Starship. At that price point, launching a data center into orbit suddenly starts to look competitive with building one on land. And that really is the crucial difference between then and now. I mean, for decades, space was a government-only game. The launch costs were just so unbelievably high that nobody else could afford it. But today, the entire economic model has been turned on its head by the commercial space industry. It's unlocking possibilities that we could only dream about just a decade ago.
And if they succeed, the impacts are going to be profound. First, this could completely disrupt the multi-trillion-dollar cloud market that's dominated by Amazon, Microsoft, and Google. Then, you unlock the potential for a whole new generation of apps, things we can't even imagine yet, that need to process data directly from space with almost zero delay. These orbital centers would also be the ultimate disaster recovery plan, a backup for all of humanity's data that's totally safe from floods, wars, you name it. And just think about the geopolitics. What does a sovereign cloud even mean when it's constantly flying over everyone's heads? It challenges every space treaty we have.
And this long-term vision, it's something all the key players share. Jeff Bezos thinks moving heavy industry and huge computing centers off-planet isn't just about cool new tech. It's about making Earth a cleaner, better place for us to live.
So, as we watch this incredible race unfold, the real question isn't just about whether they can solve the engineering problems. It's about who gets to write the rules for this new frontier. Because once our most important information actually lives among the stars, the question of who owns it and who controls it might just be one of the most important questions of our time.